There are some targets, however, such as bridges, on which we can concentrate on one aim factor at the expense of the other. For instance, here we can approach in a shallow dive up or down the bridge and concentrate on correcting deflection. The length of the bridge will allow plenty of margin for normal range error. Or we can approach in a steep dive directly across the bridge and concentrate on correcting range, because the length of the bridge will allow plenty of margin for any normal error in deflection. In the previous examples, we assumed that the airplane was flying through still air. Actually, still air is the exception rather than the rule. Therefore, in dive bombing, we must make accurate allowances for the drift of the wind. Assume we are in a dive and have an accurate bead on the target in both range and deflection. Now let's add the factor of the wind blowing sidewise on the airplane. This horizontal wind will drift the airplane sidewise during the dive, moving our line of sight off the target. Let's repeat the dive and allow for this drift, so our line of sight is on the center of the target at release altitude. When we release the bomb, however, we find that it retains the airplane's sidewise motion just as it does the airplane's forward motion. So the bomb is now falling sidewise too. Because this sidewise motion will carry the bomb off the target, we'll still fail to hit. Therefore, we must allow for the drift of the airplane before release altitude, plus the drift of the bomb after release in order to make a hit. If the wind with which we're drifting during the dive remains constant, it is the effective wind. If the wind with which we're drifting during the dive varies, the wind drifting us at release altitude is the effective wind, since this is the wind drifting the bomb as it falls. We'll see in a later film that the wind about 500 feet above release altitude is the effective wind. With knowledge of the effective wind, the wind affecting the airplane at release altitude, we'll be able to select our tentative point of aim on a stationary target far enough upwind from the target to allow for the bomb's drift after release. We must also allow for the drift during the dive. If we fail to allow for this drift, we must continually turn to keep on the tentative point of aim. In moderate winds, the turn is so sharp that it becomes difficult. In strong winds, it's impossible. So we select a pushover aiming area far enough up the winds through which we dive to allow for the drift to the tentative point of aim. We push over on that area. As we dive, the moving point of aim travels toward the tentative point of aim. We can easily make small corrections in our dive up to the point of release. So by the time we reach release altitude, we should be aimed in deflection at the tentative point of aim. Just before reaching release altitude, we go to our sight and correct our aim in range. This final correction gives us our release point of aim. In the previous examples, we've assumed that the targets have been stationary. In most instances, however, dive bombing targets are moving to get away as fast as they can. Now let's assume that our range, deflection, and wind are all taken care of, but that the target is moving. We drop the bomb and miss because, in the few seconds it took for the bomb to fall, the target has moved out of the way. In order to hit a moving target, we must figure out how many feet the target will move forward while the bomb is falling. Then we must aim that distance ahead of the target center, so that the target and the bomb will meet. Let's try again. This time we'll aim ahead of the target. We release the bomb. And bang! We score a direct hit. There's nothing haphazard about dive bombing. After the basic principles are understood, the rest is the practice that makes perfect. Maybe we won't put all the shots down the stack, but we can put them where they count. Let's review the steps to take. First, we identify the target. Then we pick our point of aim and start our approach. We enter the dive, allowing for the drift of the wind and the motion of the target. We make our smaller corrections to get the final point of aim. We release, pull out, and score a hit.